Type 5. Two pipes separately can fill an empty cistern with water in X minute and Y minute respectively. The cistern is completely empty. Both the pipes are open together to fill the cistern. When will the first pipe need to be closed so that the cistern be completely filled by first and second pipe in T minutes? The question asks to find when will the first pipe need to be closed so that the cistern will be completely filled by first and second pipe, that is for the both pipe in T minutes. Let the volume of the pipe is V, and again let first pipe need to close after T minutes. So both the pipe were open for T minutes and only second pipe was open for T minus T minutes. Here this T is the total time given here. So T minus T minute. This T is the time we want to find here. So both the pipe were open for T minutes and the only second pipe open for uppercase T minus this lowercase t minutes. So step 1, Q in 1, that is V by X for the first pipe, and Q in 2, that is V by Y for the second pipe. And find the amount after unit time, that is Q in 1 plus Q in 2. This one is amount after unit time. So final equation is, so T into Q in 1 plus Q in 2, since both the pipe are open for T minutes and this T minus T minute, just the second pipe was open. So T minus T into Q in 2, which the total amount will be the full volume of the tank. So the substitute the value of Q in 1, which is V by X, and Q in 2 is V by Y here. That is Q in 2 is equal to V by Y. Then if we simplify, that is we get T equal to xy minus Tx divided by Y. This is our required time. After this time T, first pipe need to close to fill the tank with both the pipe. So let's see one example of type 5. Two pipes separately can fill an empty cistern with water in 10 minutes and 15 minutes respectively. The cistern is completely empty and both the pipes are open together to fill the cistern. When will first pipe need to close so that the cistern is completely filled by first and second pipe in 9 minutes? Let the volume of cistern is V, and again let the first pipe need to close after T minutes. So both the pipe were open for T minutes and only the second pipe were open for 9 minus T minutes. So first the flow in for the first pipe, which is V by 10, and flow in for the second pipe, which is V by 15, and the amount after unit time, that is Q in 1 plus Q in 2, since both the pipe are for Q flow in. Final equation, this T into Q in 1 plus Q in 2 and plus 9 minus T into Q in 2. Here, since both the pipe are open for T minutes, that's why Q in 1 plus Q in 2 into T, and only the second pipe is open for 9 minus T minutes. That's why 9 minus T into Q in 2, which gives the total value, that is the volume of the tank. So substitute the value of Q in 1 here and Q in 2 here. We now simplify the equation to find the value of T. That is T equal to 4 minutes. This is our required result. So if we use the previous formula as a shortcut of this type of problem, then the shortcut will be xy minus Tx divided by Y. Here this X is a flow in for first pipe, this Y is a flow in for the second pipe, and this T is a total required time. If we substitute the value from this problem, that is the value of X is 10, value of Y is equal to 15, and total T required time, the value of T is 9. So xy, that is 10 into 15, minus t into x, that is 9 into x, that is 10, and divided by the value of y, that is 15, which gives the value 4. Type 6. A tank is filled in x minute by a pipe. Another pipe flow out y liter of water in 1 minute. When the tank remains empty, both the pipes are open together. The tank is filled in t minutes. What is the volume of the tank? This type of problem is to finding the volume of the tank. Let the volume of the tank is V. And for the first pipe, the flow in, that is V by X, and the flow out here, the y liter of water in 1 minute. So y divided by 1. Amount after unit time, flow in minus flow out, that is Q in minus Q out. And the final equation is T into Q in minus Q out, which is equal to V. Here T is the total required time when both the pipe are open. So substitute the value here, that is Q in equal to V by X, and the Q out is equal to Y. Now simplify the equation to get the value of the V, that is V equal to Txy divided by T minus X. This is our required result. Let's see one example of this type, that is a tank is filled up in 10 minutes by a pipe. Another pipe flow out 2 liters of water in 1 minute. When the tank remain empty, both the pipes are open together and the tank is filled in 15 minutes. What is the volume of the tank? Let the volume of the tank is V, and the Q in, that is flow in, is V by 10, and the flow out, that is 2 liters of water in 1 minute, that is 2 by 1. The amount after unit time, that is Q in minus Q out, and the final equation, that is when both the pipe are open, that the required time is 15. So 15 into Q in minus Q out, which is equal to V. Substitute the value of Q in, which is equal to V by 10, and Q out, which is equal to 2. So simplify the equation for the V. We get V equal to 60. So this is our required result. The volume of the cistern is 60 units. Now if we want to solve this problem using the shortcut will be Txy divided by T minus X. Here the X is 10, that is the required time to fill the tank or cistern by a pipe, and this Y is the flow out rate, and this T, when both the pipes are open, the required time to fill the tank. So Txy divided by T minus X, which is the volume of the tank. So here the value of T is equal to 15, the value of X is 10, and value of Y equal to 2. So 15 into 10 into 2 divided by 15 minus 10, which gives the volume of the tank, that is 60. Now type 7. 2 pipe fill a tank in X minute and Y minute respectively. Another pipe flow out water from the tank. When the tank remain empty, 3 pipes are opened, then the tank is filled in 3 minutes. How much time need to flow out the full tank by the third pipe? So let the volume of the tank is V. So step number 1, find the Q in, that is for the first pipe, the Q in is V by X. For the second pipe, Q in is V by Y, and Q out, that is Q out for the third pipe, that is Q out the full volume. Let the time required time is T, so the Q out is V by T. We are going to find the value of this T, that is the required time to flow out the full tank by the third pipe. Let that time is T, so V by T is Q out. So amount after unit time, that is Q in plus Q in minus Q out. So final equation is the total time into Q in plus Q in minus Q out, which gives the total volume V. Substitute the value of Q in, that is V by X, for the first pipe. For the second pipe, the Q in is V by Y, and third pipe V by T. We are going to find the value of this T. Now simplify the equation to find the value of t here. So we get t equal to xy t divided by yt plus xt minus xy. This is the required time for the third pipe to flow out the full tank. Let's see one example. Two pipes can fill a tank in 10 minutes and 15 minutes respectively. Another pipe flow out water from the tank. When the tank remain empty, three pipes are open, then the tank is filled in 15 minutes. How much time need to flow out the full tank by the third pipe? The volume is here V. Flow in for first pipe is V by 10, flow in for the second pipe is V by 15, and flow out is V by T. Here the flow out for the third pipe, the required time, let the required time is T to empty the full tank, that is V by T is the flow out for the third pipe. We are going to find this value T. The amount after unit time, Q in plus Q in minus Q out. And the final equation, that is the total time when all the pipes are open, that is 12. So 12 into Q in plus Q in minus Q out, which gives the value is total volume V. Substitute the value of Q in V by 10, another Q in that is V by 15, and the Q out V by T, which is equal to V. Simplify the equation to find the value of T here. We get T equal to 12. This is our required result. So if we want to solve this type of problem using the shortcut, the shortcut will be xyt divided by yt plus xt minus xy. This x is the required time for the first pipe to fill the tank. This y is the required time for the second pipe to fill the tank. T is the required time when all the pipes are open. So this xyt divided by yt plus xt minus xy, which gives the required time to flow out whole tank for the third pipe. So here x is equal to 10, y is equal to 15, and this t equal to 12. So if we substitute the value here, we get the required result 12. Now type 8. There are two pipes in a cistern, one of which can fill the cistern in x hours. If both the pipes are open together, it takes t hours to fill the cistern. Find the required time for the second pipe to fill or empty the cistern or tank. Let the volume is V. So Q in for the first pipe is V by X and Q in for the second pipe is V by T. We just let here the required time for the second pipe to fill the tank is T. So we are going to find the value of this T. So amount after unit time, that is Q in plus Q in, since both the pipe are for fill the tank. So simplify the equation T into Q in plus Q in, which is equal to V. Substitute the value of Q in here, V by X, and Q in for the second pipe, V by T here. And simplify the equation to get the value of this T, which is xt minus x minus T. This is our required result. So let's solve one problem of this type. There are two pipes in a cistern, one of which can fill the cistern in 10 hours. If both the pipes are open together, it takes 8 hours to fill the cistern. Find the required time for the second pipe to fill or empty the cistern or tank. So let the volume is V, the Q in is V by 10, and for the second pipe the Q in is V by T. We are going to find the value of T here. Since both the pipe are for flow in, so amount after unit time is Q in plus Q in. The final equation is 8 into Q in plus Q in, which is equal to V. That is, when both the pipe are open, that it required 8 hours. So total time is 8, and this one is amount after unit time. If we multiply with 8, which give the total value, that is the volume of the tank or cistern. So substitute the value of Q in here, V by 10, and the value of Q in for the second pipe, that is V by T. We are going to find the value of this T. So simplify this one, we can easily get the value of T, which is T equal to 40. This is our required result. And if we want to solve this problem with using the shortcut formula, then the shortcut will be xt minus x minus t. Here x is the required time for the first pipe to fill the tank. This t is the total required time when both the pipe are open. So xt divided by x minus t, which gives the required time for the second pipe to fill or empty the system. Here the value of x is equal to 10 and value of t is equal to 8. 10 into 8 divided by 10 minus 8, which gives the result is 80 divided by 2, which is 40.